Now let us see the force acting on a body which is horizontally placed inside a fluid. So here suppose this is our coordinate system and we have a surface that is horizontally placed. This is your XY surface and Z is here. So I have not shown the fluid is above, so the fluid height is along Z axis. This surface is totally submerged in this. So a horizontal surface immersed or submerged inside a liquid is under a constant pressure. So thus if we have an arbitrary surface in bracket horizontally placed, horizontal on XY plane, then the hydrostatic force acting on it is given by the equation F is equal to PdA. Now since the pressure is same at here, so we will have P into the area A. So this is the total force acting on this. So now you see, this is, remember, this force is on the one side of the surface. So a surface will have two sides, so only one side. Now let us see that what is the line of action of all these forces. Means, you see, if I take a small element here, then the pressure due to this hydrostatic force is here. If I have a element here, and if I have an element everywhere, the force is here. So if I want to know the line of action of this force, then we will take some moments. So let us see. So let us now see the line of action of these forces, hydrostatic forces. So this is the total force, that is P into A. So in order to know the line of action of a force, we have to take moment of all these pressure forces. So what I do, so this is a small elemental area, I say it is dA, and the force is acting downward, so I say it's P into dA. And you see, this force can produce a rotation about this. So this force can produce a torque. Similarly, here is also a force acting, and this will also produce a torque. So what I mean by the line of action of a distributed force system is that if I denote the total force as PA, so it is from which point it should act so that it produce the same moment about any line. So suppose I take that line OY. So OY means this distance becomes X. So this is the X coordinate and this is the Y coordinate of this elemental area. So we have to see the line of action. So the line of action will pass through a point from where the total force F is equal to PA should act so as to produce the same torque which the distributed force system will produce about any axis. So presently I have taken, suppose, OY axis. So now suppose the PDA force applies a torque, so that torque will be written as this X, this torque will be written as, total torque will be X times this force PDA, and this is the total torque. Now if I say that this torque is equal to, suppose this point is, that is X bar, I say X bar is the point through which the center of the pressure will act, then this P into X bar. So this is P, that's not P, that F, total F, that is where F is equal to P into A, total area A. So this is the torque due to the total pressure force, and that is equal to the torque of all the distributed pressure force about OY. So this is P into area into X bar is equal to X PDA. Now since P is constant, I can take out, and so X bar, that is the position of the line of action, will become 1 by A times integral X P by dA. So this X bar is called X, this P cancels out. So integral X dA by A is also called dA. So thus you see, we know that the RHS represents the centroid of the area. That means the whole pressure acts at the centroid. So you see what is our conclusion now. So suppose this is the area, on this area we have pressure forces acting downward like this. I can say that there is only one pressure force acting, that is the P into area, that passing through the centroid of this area. So the resultant, the total force acting is equal to P into area, and the point from which it is acting, that point will have a special name now, that the center of pressure force. So now let us summarize it. So thus the center of pressure force on the horizontal area is its centroid, and the total force and F total will be equal to pressure into area.